So we are going to continue to talk about how to implement a stack using the linked list concept. In this video, in particular, we are going to talk about how to implement the stack structure itself. Now, we've seen how we can use the node class to build a very generic linked list. Now, linked list is a data structure, and a generic linked list can actually be used to build other data structure, such as a stack or a queue. Okay, now the main difference between, say, a stack and a queue that's built on top of a linked list is where to insert the new data and where we can retrieve or remove existing ones. Right? For a stack, we insert at the top and we remove at the top, right? And for a queue, we insert in the front and remove at the end. Now, so we'll start with the stack because a stack is something that we've studied before, and it's also fairly simple. So it's one that's kind of easy to get into. And we also, because we've been studying inheritance, we will actually imply the idea of inheritance in this whole process. So the first thing we'll do is that we'll build a stack class that will kind of takes care of the how to structurally build a stack. And then we'll have a data stack that inherits from the stack class that we built. And that the data stack would, as the name kind of implies, it will add the ability to store data on top of the structure of a stack. So with a stack, if you remember, one of the most important attributes is where the top of the stack is, right? Because that's where all the push and pop operations are. So top of the stack, where should it point to? Well, in a linked list. Well, there's an obvious candidate, right? How about just the very first node? And also it's important to see that now with a single reference or a single pointer to the very first node in the entire linked list, we can reach the rest of the linked list by traversing using the next pointer, and next pointer, right? We can get to the entire all the content in the linked list. So okay, the first node is special because it's the top of the stack. What about the next pointer? Is there one out of all of these next pointers that are kind of special? Well, what is the last next pointer? What should it point to? So that we know that's the very last one. Well, the last one usually it points to none, or pictorially, I like to draw it as for those of you who know a little bit of electrical engineering, this is the symbol for ground. So it basically points to nothing. So when we traverse the linked list, and when we get to the node whose next pointer is pointing to none, then we know we reached the end. So keep these two things, keep the top in mind, and also keep the last next pointer in mind as we talk through our stack implementation. So as usual, when we start implementing a class, we start with the initializer under init. And because we had, for the stack, we have one very important attribute, the top attribute. So we're going to have to create that attribute, self.top. And to begin with, we will set it to none because the stack is started as empty, right? So, so you might ask, okay, well, top is eventually going to point to a node. Why don't we create a node and have top point to it? Well, if we set top to a node, that would have meant that the stack already has one element in it, right? So it already has one node. So so that's why we shouldn't do that, right? We want to start with an empty stack. The next method we're going to look at is the push operation. Now, I'm going to do something a little different from what I usually do, which is I am going to actually go through all of my slides and show kind of the pictorial representation of the stack operations before we would actually try to code. Whereas I usually, try to write code and talk through the concepts at the same time. Now, the reason for that is to really kind of understand how linked list works. It's really, really important that we draw pictures and make sure we know what happens to all the pointers and how they change in each of the operations. So I encourage you to actually take out paper and pen, a pencil, and draw the picture along with me. All right, so the push up operation is going to take a new node and it's going to add it to the stack that usually already has quite a few things in it, right? So here the picture, the stack currently only has one node, but it can be easily generalized to have it already having multiple nodes. So okay, so where do we want this new node to go? So we know that the push operation always put the new whatever thing as the top of the stack. So we want the top attribute to point to the new node, right? And in order and also to get to what's were already on the stack before this push operation, then the new top of the stack next pointer should point to what's already there, which means um, the next pointer should point to what the old top is pointing to. Okay, so now then the question then becomes, okay, how do we make this happen in code? Well, so here is kind of a step-by-step or line-by-line uh, explanation of the implementation for push. So the first thing we want to do is that um, given the new node, we want to assign the old top, right, which is pointing to this node, to the new nodes next. So we want to have the new nodes next to point to the old top. So that's what that line accomplishes. And then the next thing we want to do is now we want the top to point to the new node. So that's the goal that we originally set out to do, and that's what these two lines would accomplish. Okay, so this would work if the stack already has some nodes in it. So immediately we might have a question on then what if there was nothing in the stack to begin with, that the top was pointing to the ground or none at the beginning? Would these two lines of code would it still work correctly in this case? And I would encourage you to pause the video and think about it, draw the picture out, and see if it actually works. So the answer is that yes, it would, because the first thing, when we assign the self.top to node.next, is basic self.top is none, right? So that means node.next, it would point to none. And then the second line would point self.top to the new node. So we would end up with a picture like this, which is exactly what we want to do when we're pushing one node onto an empty stack. Another good exercise for this would be, well, this method is fairly simple. It has two lines. What if we swap the order of these two lines? And would it still accomplish what we wanted to do? All right. Assuming you have some time to think about it, the answer is no, it won't. So if you actually follow what they do and draw the picture, you'll end up with a picture like this. That the first thing is self.top. It's going to point to the new node, right? That's this arrow. And then we say no.next is going to equal to self.top. So no.next, no.next is going to be self.top. So it's self.top is basically the node itself, right? Because we previously assigned node to self.top. So it's just basically making the node.next pointer to point to itself, which means we are going to lose everything that was originally on the stack before the new node was pushed. So be very, very careful when we write code that manipulate linked lists, because the order really does matter. Okay, now let's look at what should happen in a pop operation. So let's see what our goal is, right? So assuming we originally have two nodes in the stack, we want to return the node that is pointed to by top, right? And then we want to update the top to point to the next node in the stack, right? Okay, so how do we accomplish that? So here is how we write the pop operation. So the first thing is we will assign the current top to a temporary variable. We'll just call it node. So node points to the original top. And the next thing is we're going to change top. We're going to change self.top to point to what self.top next was pointing to previously. So basically, we're updating the top to point to the next next node in the original stack. And the next thing we do is we will kind of set this next pointer in the original top to point to nothing. And then finally, this is the node that we want to return in a pop, because that's the original top, right? So we will just return node. And what we're left inside the stack then is the linked list minus the original top. Now we can answer one of the question I kind of glossed over just now, and that is, why do we want to set the node that we return next pointer to point to nothing? Well, if we keep the next pointer pointing to what it was pointing to before, that would give whoever gets hold of this node a way into the stack, right? Because that pointer would point to the current top of the stack, and that's one of those internal implementation details that we kind of don't really want the client code to have access to. So that's why we set this to none before returning it. So now a couple questions to think about. First, as before, we should think about the corner cases, right? So in this case, the corner case is we're trying to pop something off the stack. Well, what if the stack is empty? Does the code as written, does it still work? Well, the answer, hopefully you've kind of stepped through the code line by line and draw the picture, and you hopefully see that no, in this case, this won't work. And that is because when we try to do self.top, which points to none, and then dot next, we're effectively doing none.next, which obviously won't work. So this would crash the code. The next question is, kind of as in the case of push, what if we swap some of the lines? For example, if we swap the top two lines, does the code still work? What would the picture look like in this case? Okay, so hopefully you have had some time to think about it. So here is what I draw up. And in this case, it will do the wrong thing again, because again, order is very important. So what happens here is when we say self.top equal to self.top next, well, it makes the top to point to the next node in or the second node in the original stack. And then we say node now is equal to the self.top, and so node will also point to the second node in the original stack, and that's what it's going to return. So it would, instead of returning the top of the original stack, it will return then the second node of the original stack. So it's the wrong node. So I know so far we've written quite a few lines of code, but we haven't run them yet, which is very unusual because I like to advocate that we test the code as we write them. Now, the reason for that is first, again, as I said before, I would like to focus our attention on drawing the pictures along with writing the code. And also, secondly, we haven't written a useful done the string method yet for the stack, and that's what we will fix in our next video.